Morning. This week we're still on Unit 2, but we'll be looking at the switch and vectors. So 2.5, if you go in there, that's the material for 2.5.1 switch. That's the open book quiz. And this week we'll be writing up on 2.5.1 and 2.6.1. 2.6. The 2.6.1 is its vectors. So we'll start looking at a switch or switch statement. Remember when you looked at an if cascade, you said it's an if statement followed by another if statement, and you can have as many as you can. But if you have many if, or you can say if cascade statements, sometimes it becomes hard to read, and it's hard to add new if statements into the cascade. And sometimes you would want to remove some of the branches, and that would be a bit hard for you to do that. But if it's more like this, then it's easy. But if you have more conditions and an expression to check against, then it will become hard for you to read that and to remove some of the branches or to add new ones. But there's an alternative to that, which is the switch. So this is a program in an if statement or if cascade, and this is the same program where we used a switch. So to see how it works, let's look, for example, the first condition and the first statement. It says if I is equals to 1, then print out that only 1. And if you look at the switch, it says switch I in parentheses, then case 1. It's like if I is 1, then print out that. Then at the end you have a break. And the second one, else if I is 2, do that, print out I want more. You can see from the switch I, if the value of I is 2, we use that case and a colon, then that must be printed out if I is equals to 2. Then a break at the end of that statement. That break means that the break at the end of this statement means that you are terminating the compilation of that statement. Sure. If there's no break, like for example, if I is equals to 1, then there is no break. Then it will continue to case number 2, and it will also print out that I want more. We'll see from an example here. Say switch I. You see in case number 3, there's nothing to print out and there's no break. So if I is equals to 3, then it will come here and check anything to do with if I is the value of 3, then there's nothing and there's no break, then it will continue to case number 4 and it will print out okay. Do you get that now? Sure. And then there's also a default keyword that I can say it matches the else, that last else statement in an if cascade. If you look at this one, if we enter a value of 1, that will be printed out. A value of 2, that will be printed out. A value of 3, and that will be printed out. But if it is not any of these numbers, 1, 2, or 3, then it will print out okay. The default keyword also gives us that option. When the value we give does not match any of the cases that have been specified, then it will print out that don't care. If our I, for example, is 5, and there's nothing to do for 5 here, then it will print out don't care, which is the default. And things to remember is that the value after the case cannot be an expression. And the way that these statements are executed, it's in the order that they appear. So that will be the first one to be executed or checked against, and that the default will be the last one. Because that's, do you have questions? No. Then we can look at vectors. So the variables that we have been declaring so far in previous examples, if you declare one value for a variable, that is called a scalar. But there's sometimes when you have to declare multiple variables. If you look at here, all these variables are of type int. They are all integers, and there's a lot of them. There's 9 of them. So this is what we have been doing, which is called a scalar. But there's a shorter way of doing that using vectors or arrays. So in here we declared 9 variables of type int. And you can see that it is correct, but it's very long. And to shorten that, we use an array. An array can only store values of the same type. You see those numbers, all of them are of type int. Then we can declare an array of type int, which means all the values or numbers stored in that array will be of type int. Numbers, that is the name of the array, the identifier. And the value inside the square brackets is the number of elements, the maximum number of elements that can be stored into that array. And all those numbers must be of type int. So if you want to assign a value to the first element of an array, so the first element of an array is indexed 0, and the second element becomes 1. Let me show you. So if this is our array, the first element which goes here is indexed 0. The second, that is first, 2, 3, 4. And the second becomes 1. The third is 2. The fourth is 3, and the fifth, no. And the fifth element will be indexed 4. So, and if we want to put in the value of 101 into the first element, this is how we do it. That's the array, the name of the array, and that is the index of the value where we want to put it in, and that element would be 101. So in this case, that value that goes here will be 111. And then if now we want to store the value in the third element, and we want to assign it to a variable called I, then we can say I. Remember, the third element is indexed number 2, this one. Then in here, if you want to store a variable named I, then that is how we do it. I equals to numbers, and the numbers, which is the name of the array. And then the index where we want to store that variable in, which is the third. And if you want to copy one element, a value from one element to another, let's say the value at index 1, we want to copy the value at number 4 to number 1. So we say that the value at 1 should be equals to the value at number 4. So in this case, that value, if we didn't have a value at index number 1, then you want to copy this one at number 4 to number 1, then that would be number 4. This is what that is going to do. And this is an example that will calculate the sum of all the elements inside an array. So if that is the array, it's all integers, and it contains five elements. The sum initially is 0. Then the sum would be all the numbers in that array, the sum of all the numbers in the array. In this case, if we had take that back. So what this example will do is it will add all the numbers inside the array 2, 4, 6, 8, 10, and it will give you the total sum. And the following example, it says numbers in that array numbers. All the values of I will be equals to 2010. So in this case, all the numbers in the array will have this same value of 2012. So in there, you'll have 2012 in all the boxes. So in this example, I want to show how we can swap values inside an array, but we'll first do it manually. Like if we have a variable of I, let's say A equals to 1 and B equals to 2. So that will be 1 and 2. But we want to swap them such that A becomes 2 and B becomes 1. And how will we do that? Because if we say A is equals to 1, no, actually, if you say A will be equals to B and B is equals to A, then in this case A will be 2 and that value of 2 will be kept. Now if you say b is equals to a, it will take the last value of a, and b will also be 2. Then you see that it will not work. How do you think we can do that? Does anyone have an idea? Sure.
Why don't you add another variable?
Add another variable.
Then you put what? C is gonna be
C can be as
set as A, and then you say no.
C can be a placeholder.
Yeah. C will be set to
You can say C is equals to A. So C will be 1. A equals to B,
and then B set to C.
then B is set to C. So A will be equals to A will be equals to B, which is 2, and B will be equals to C, which is 1. Then we've achieved that. That's good. But what if you have, come on. But what if you have, what if you have more variables to swap? 50. That is the example that we did now. We introduced a new variable. In here they used auxiliary, which will be our C from our previous example. And in here they used an array and a for loop to do that. And you can use a for loop and an array if you are asked to swap numbers that are maybe larger, maybe like 20 or 100. So let's make an example of 5 elements. 10, 20, 30. So we want to swap this such that it starts from the first element is 50, the second is 40, 30 remains where it is, then 20, then 10. So with the use of a for loop, you have a variable named I. Come on. No. can put I, which is equals to 0. Then our condition, we check if I is greater than 2. Then we increment I. Inside the for loop, they have aux, which is equals to I. Let me just then the value of the value at the element of I, say I is 0. So the value at 0 would be the value at 4 minus 1 minus I. In this case, it will still remain 4. So what is the value at index 4? That is 50. Remember, this is 0, 1, 2, 3, 4. So the value at I, which is 0, will be 4 minus 0, which is the value at 4. So that will become 50. Do you see that? Then the value at 4 minus 0 should be equals to the auxiliary. The value at 4 minus 0, which is 4, the value that must go there, that is 0, 1, 2. The value that must go to 4 should be auxiliary. Auxiliary, we said, is I. And firstly, I is 0. Should be that value there at 0. So that would become 10. And then I is incremented by 1. So I will be 1. And we check, is 1 still is 1 less than 2? Yes, it's 2. Then our new value for aux is I, so which is now 1. And the value at I, at index I, now it's no longer 0, it's 1. The value that must go there should be 4 minus 1. The value at 4 minus 1. The value at 3, which is 40. And the value at the value at 3 from there, which is 4 minus 1, should be the value at the auxiliary now, which is 1, which is that one, 20. So 20 will go there. And then I is incremented by 1. I becomes 2. Then that test expression now is false. Then 30 remains where it is. Then you see that we've swapped that whole array. So, okay. So instead of swapping numbers one by one, large numbers one by one, then you can use a for loop and an array. That's the end of today's lesson.